Dear students, a very warm welcome to the physics class. Uh, this is our first day together, so naturally I would like to begin by the introduction to the syllabus, what exactly we are going to study in this class in the first year of this A-level. AS Physics, as I have written briefly, it comprises of 13 topics we are going to cover, and these 13 topics are covered in 3 different exam papers. Paper 1, which will carry 21% weightage, is multiple choice questions, and the duration for this paper will be 1 hour 15 minutes. This paper is generally considered very challenging, and unless you have very strong concepts in physics in the AS, you will have tough time attempting this paper. Paper 2, which is relatively easier paper and it has larger weightage, it is structured question similar to paper 2 that you used to have in the O-levels. And it has the same duration, 1 hour 15 minutes. This is 40 questions in it, and each question is carrying 1 mark. So this is 40 marks paper. This exam paper, paper 2, which is structured questions, this is 60 marks paper. And paper 3, which is 23% weightage out of 100%, this is practical exam. And this exam, for which you will have a regular timetable, you will be visiting to the physics lab at least once every week. This practical exam will have 2 questions in it. Each question will be of 20 marks, and the 2 questions in this exam paper, it will be again 40 marks. That means the total 140 marks in the AS. So this is the brief overview. I hope you all are comfortable with this, and most of you might have already gone through this detail. So without wasting any more time in the introduction, I would like to start with the very first topic, which is about the physical quantities and units. Physical quantities and units is our first topic, and as the name of the topic is suggesting, this is about what we. This is about the quantities that we measure in physics. That means this is something that deals with the measurement of the physical quantities. Physical quantity, let's define what physical quantity is. Physical quantity Physical quantity is something that we can measure. All objects have some measurable features about them. For example, this whiteboard has a certain height, a certain width, a certain mass, then we weight, it has a certain weight, it has even its hardness. All these things are its measurable aspects, its measurable features. So these measurable aspects or measurable features are known as the physical quantities or in physics. So physical quantities in physics means the measurable features of an object. There are many quantities that we cannot measure. We refer to them as abstract quantities, such as the patience, the love, stamina. These things are known as abstract quantities. And physics does not deal with those quantities that we are unable to measure. Physics deals with these quantities uh, which we can measure, and these physical quantities are divided into two main groups. One group is known as base quantities, and the other group is referred to as derived quantities. Base quantities are those which do not depend on any other quantities for their definition. They are independently defined. Base quantities are the physical quantities which are independently defined. Independently defined quantities. And obviously, derived quantities are not independently defined. They depend for their definition on these quantities. They depend on base quantities for their definitions. An example of independently defined quantity is mass. Another example is time. Yet another example is temperature. Another example is length. And one more example is electric current. So there are 5 quantities which are independently defined. There are 7 in fact, but 2 of them will be covered in the A2 physics. But these 5 will be talked about, these 5 will be discussed, defined, and they will be frequently used in the AS physics. I repeat, mass, time, temperature, length, and electric current. These are 5 base quantities in the AS physics. On the other side, derived quantities is a long list of quantities, and they start with such basic, simple quantities as density, speed, area, volume, and then more important quantities such as force, pressure, energy, momentum, electric field, and so on and so forth. It's a long list. As we move through the syllabus in the AS, we'll come across these quantities and we'll learn more about this. But at this stage, in this very first topic, we are supposed to know the symbols of these quantities, uh, and how they are expressed in base quantities, especially these derived quantities. We must know how they are expressed in terms of these base quantities. So let's come to that part of discussion. If I start with the base quantities, as I said, mass is one of them. Its symbol will always be small m. But the unit in which it is expressed will be kilogram. So let's not be confused by this symbol. We focus on the symbol for the unit. Mass will always be expressed in kilograms, and the symbol for kilogram will be kg, and k is always be small k here, with g small again. So kg is mass. Length will always be expressed in meters, and small m uh, will always be the unit for meter. Temperature will always be expressed in Kelvin. If I write full name, Kelvin, this is meter, this is kilogram, but we do not have to write them in full. We always express them in terms of their symbols. Kelvin is capital K. Electric current, is expressed in ampere, and that is capital E. And then time is expressed in seconds, and that is small s. So these are the 5 base quantities. And now the list of derived quantities. Derived quantities, you can start with area, which is meter square, then volume, which is meter cube, then density, which is kilogram per meter cube, because this is mass over volume. Then we have force. Force, since it is mass times acceleration, so this must be kilogram meter per second square, because this part is acceleration. Let me write it as separate quantity as acceleration here. Acceleration will always be meter per second square, because we know this is distance over time square. And if I add speed to this list, it will be meter per second, because this is distance over time. You must have noticed that I am not writing it like this. Meter per second is not allowed in this manner. We must express this s with -1 power instead of writing is in the denominator. So meter followed by a slash and then s will have entirely different meaning in the AS. I'll come to it later on. But you will remember this is not allowed to express it in this way. So meter per second will be written in this manner. Meter per second square will be written like this. That means we will be using negative powers of the quantities here in the denominator. Similarly, we can move on to another physical quantity which is work. Work, as you know, is defined as force into distance. Force into distance. So force, which we have already learned, is kilogram ms minus 1 times distance, which is meter. So if I multiply these two quantities, which are obviously the same quantity, it becomes meter square. So it becomes simply kilogram meter square per second. So this is work. Work and energy will have same units. You remember this because energy is the capacity to do work. So energy is measured in the same units. Although we do not express it in this way, it's not force into distance, but since it is simply the capacity or capability of doing work, so energy is measured in kilogram meter square per second, which has a special name, and we know it as joule. So work is measured in joules, energy is measured in joules. And 1 joule simply means 1 kilogram meter square per second. Then we have pressure, another important quantity that we will study in the AS in detail. Pressure, it is defined as force over area. So once I know force is kilogram meter per second and divide it by area, which is meter square, as I wrote it at the top, I simplify it, and this meter, when taken to the top, it becomes m minus 2 if I remove from here, and when I further simplify it, it will become with this 1 and with this minus 2, it becomes minus m power of this m. So kilogram m minus 1 s minus 1. So I have simplified by using these SI base units, and this is the final shape of the unit in which pressure is expressed, and a more familiar name of this is Pascal. Similarly, another quantity that we'll deal with in the AS is momentum. Momentum, as we'll define it later, it is mass time velocity. So mass into velocity means it will be kilogram meter per second. It's a vector quantity, and obviously when we talk about this in more detail, we'll be mentioning its direction as well, but as long as its unit is concerned, there is no distinction between speed and velocity, between a quantity being vector and a scalar. The units will be same. Length and displacement will have same units, both are measured in meter. So momentum is kilogram meter per second. This is mass into velocity. So this is a quantity expressed in its base unit. So this is an incomplete list because there are many more quantities we can add to this list. We can keep adding to it. We can keep referring to this list. We can keep coming to this list again and again. And I will remind you how each quantity, if it is a derived quantity especially, how it can be expressed in terms of base quantities. And this is actually an important topic in the AS, and there are dozens of questions in the recent exam in which you are required to express derived quantities in terms of base quantities. Next, all right. As I said, there are questions in the exam in which you are to express some quantities in terms of base quantities. We begin with a simple quantity such as charge. Express charge in terms of SI base units. Charge is defined as current into time. So when you express charge in terms of product of current and time, you mean which quantity has what unit. We know current is expressed as ampere and time is expressed as second. So if charge is to be expressed in SI base units, the first thing we need to know is its defining equation. By defining equation, I mean how to link this charge to those quantities on which it depends. And these are the base quantities. So with these base quantities in place, we know how to express charge in terms of base units. So charge is a product of current and time, and this is one of the derived quantities, and it is AS. I mean, the unit of charge is AS. Number one. Number two, another example is expressing, let's say, pressure. Pressure is equal to force over area. Force is kilogram meter per second square. Area is meter square. And you simplify them, it becomes kilogram meter minus 1 s minus 2. You have simplified algebraically dealing with these various powers that appear in this expression and simplify the formula of the unit of pressure to kilogram m minus 1 s minus 2. This m is for meter, this s is for seconds. So this is the unit of pressure in its most in its simplest form. Another example could be of volt, voltage. Voltage or potential difference is another quantity that we deal with, and we want to know how to express the units of voltage in terms of SI base units. But before that, we need to know how exactly it is defined. Volt or potential difference is defined as work per unit charge when it is moved from one side of the circuit to the other side when charges are pushed in the circuit. So voltage is a work-like quantity which is done on unit positive charge in order to push it through the circuit. So work over charge is the formula that we can use to express voltage in terms of SI base units. Work is already mentioned here. Work is kilogram meter square per second. We can write it here. Kilogram meter square s minus 1 divided by AS. The units of charge already derived. So once you simplify this all, it becomes kilogram meter square A minus 1 S minus 2, because this S when taken to the numerator becomes minus 1 again. So this S minus 1 combined with this S minus 1 written here will become S minus 2, and this A will become A minus 1 when carried to the top. So in its simplest form, expressed in terms of SI base units, voltage is expressed in these units. This is the introduction for today. We'll continue with the same exercise in the next lecture. I encourage you all to start working as quickly as possible without wasting any more time. Go through the very first chapter, go through the questions in the past papers, the very first few questions, especially in the multiple choice questions. You will see a lot of questions of this type in which you are to express simple physical quantities into their base quantities. So as you will start seeing them, as you start solving them through these simple equations, things will start making sense to you. More of it in the next lecture. Thank you. So let me